Agenda-wise today, I'm going to focus on three topics in total. One is database utilities, especially for doing database import-export and using the SQL Loader. So we'll first look at those utilities. We'll also talk about database security, and then focus on what the final will be all about and when the final. So I hope to cover all of those details today in the next few minutes here with you. So let's start with database utilities. So this is essentially a set of tools that you're not going to be able to try out, but are available for you to learn at least at a theoretical level, I would say. So, so the topics that are covered in this particular PowerPoint deck, we have a utility called SQL Loader, direct load insert, and export import. So whenever you want to load data from text files, external files, you use the SQL Loader utility. The point is that, this is a utility that can be programmed to accept variety of inputs, different formats. But the thing is that you have to basically tell the utility what's the input file format, so it can treat your data accordingly. So that is generally done in a with a control file. That is generally done with a control file. So control file will specify what the input file is and what is the formatting of that file, etc. So as the program executes, it will produce a log file where it will write information about the data load. If any records are rejected because of incorrect data, it is going to produce either a bad file or a discard file. Bad file will contain the rejected records, and the discard file is going to contain records that basically do not meet the input criteria. What that means in a nutshell is the discard file is going to contain records that do not meet the criteria, so you can actually go back and reload the data from the discard file. So you can create kind of a batch. So you can have a bunch of different file formats, and you can have multiple input files. So as it states in the second bullet, you can see that we handle fixed format, delimited format, or variable length records. We can also manipulate data fields using existing functions in SQL, and it supports a variety of the data types. These are the things that can go in the control file. So one of the potential questions I can ask you guys is, what will go inside the control file? So in the control file, you can specify name and location of the input file, the format of the records, name of the tables where the data would be loaded, and you also end up specifying the association between the records that you are inserting from the text file to the fields that are being inserted. So you can also specify the selection criteria. So, for example, if I have 10 records in a file, and let's say I want to load data for all employees with salary greater than a specific value, then I can actually do that. So that's the selection criteria that can be specified. And of course, you can also specify the name and location of the bad file and the discard file. So bad and discard files are generally used when there's a database error. Whenever there is a database error, that's going to write information into the bad file. And discard files are used to hold records that do not meet the specified criteria. So if there is some formatting issue, then that will go into the discard file. And the point is that by looking at the output of these discard files, we can go in and try and reload the data if we so choose. So SQL Loader can attempt to load all the data by using one single control file, as long as the file formats are essentially the same. So discard files generally are optional, but bad files are not. Discard files are optional, bad files are not optional. So the log file that is generated is generally shows the activities in the load session. So you can put in the name of the control file, log file, bad file, discard file, and data file. All these things do appear in the log file. Essentially, if you're trying to look at a running session of a SQL load, then that will go in the log file. You can also get error messages, messages indicating what records may have been discarded, and also a summary of the entire data load can be done. The summary of the data load refers to how many records were rejected, how many were loaded, how many were discarded, the total elapsed time. Those kinds of parameters are available from the input. To invoke SQL Loader, use the SQL LDR command, and then we can provide a bunch of key value pairs as input to drive the execution of the SQL Loader. These are some of the examples, if you will, of the command line parameters that can be specified for the data load. You can say, like, the file names to be loaded, where is the location of the control file, etc. So a lot of good things can be specified in command line, but you can also put most of the stuff in. You can put most of the stuff in the control file as well. Command line parameters can be specified in 3 places: actual command line, or power file, or the control file. These are some rules that are utilized for the command line parameters. So Special characters are rarely added in the command line, but generally we use spaces or commas or both spaces and commas in combination for the outcome. Then we have another tool that can be used for loading data. It's called the direct load insert. It's basically an insert statement, and this generally does a block copy. What that means is that we can enhance operation doing the insert by directly loading data from one Oracle data file to another without having to actually use the buffer cache. So you're basically making copy of one table into another. The functionality is similar to the SQL Loader, but this is better performance. If you look at SQL Loader, that's using queries that are external, and it is using external queries to bring in the data from an external file and then load it. So there are different types of data load inserts, like when you're trying to copy data from one table to another. You can do this in serial or in parallel. And it can be done with either non-partition tables or with partition tables, with or without logging. So these are all the features of if you will, of the direct load insert. When we do it in serial or in parallel, it requires a commit right after the insert statement is carried out. Rollback essentially will roll back the transaction. So there is that notion of a transaction that applies here as well. Serial in a non-partition or a partition table, basically when we load data in serial, we are dealing with inserting data one partition at a time. So there is this thing called the high watermark, which basically means the high watermark essentially means a location in the file which is not accessible by the rest of the user base. And so what happens is we insert the data up to a certain point in each partition, and then when we are ready to commit the data, we just move the marker in each segment. So that is after the commit, the high watermark is updated to a newer value, and that makes the data visible to all the users. So when we do this in parallel, this happens with multiple partitions together. Again, the same story when it comes to the high watermark, but when things move in parallel, the data is inserted in each partition together, and we can, when we say parallel, we can do 3, 5, 10, or 20 partitions together. So, and if parallel direct load insert is done in a table that is not partitioned, we basically separate the job by a certain number of rows in each for the same table, and then that work is allocated to different partitions, and then that once the load is done, the result is all merged together from different temporary segments to one primary table segment. So this is what the syntax looks like for the for the insert. It says insert into new M and then select from. So this is like insert as select. We can use the append hint if we want to if you want to do serial direct load insert. We can just put this in. We can put the append hint, which I'll show you how to do in a minute. And the parallel direct load insert will require the parallel hint. Alternatively, we can just execute the command saying alter session, enable parallel DML, and then that will enable the parallel load. This is how we provide a hint. We write this comment /* plus, and then we say append */. That takes care of doing things in serial. Of course, if we want to do something in parallel, then we go and say alter session, enable parallel DML. We also alter the table and provide how many elements do we want to do in parallel. That's the degree of parallel work. And we specify that, and then we carry out the insert a select command. So the append hint is required for using serial, and parallel hint is required for using the parallel direct load insert. The logging mode can be turned on or off. The idea of logging is to have a detailed log on the session, and that will, when direct load insert is happening. And if we don't do any logging, that will make the load faster. If we use logging, that will essentially be a little bit slower because it's going to document everything as the data gets loaded. So when direct load insert is done with logging, it will have ability to recover. But if it's done without logging, then we cannot really undo. If a job crashes in the middle, then we have to essentially start all over again, from the beginning. So, and that's the syntax for enabling the logging. So we can also do index maintenance. We can either turn it off and then rebuild the indexes, or we can build the indexes while the insert happens. So that way the indexes are updated. Again, there is a cost of performance when we are doing the direct load inserts in when we are doing the direct load insert in with the indexing turned on. So, and we can also make sure, when direct load insert happens, when we are working on tables or partitions, we enable exclusive lock on all the partitions that are being updated. And then those locks are released once the update is done. So these are some restrictions to deal with direct load insert. I think you can go through this bulleted list on things that are, it says like it should be the first and only DML statement in an entire transaction. It does not support referential integrity. cluster tables are not supported. And if you're working with a non-partition table, no index maintenance can be done. And you cannot use direct load insert with columns that have object definitions. You learn about those in PLSQL. Or if there are any log columns. So the benefits of direct load insert are essentially to improve performance significantly. So then we have export and import. Utilities that can be used to move Oracle data in and out of the database. So we do an export to write Oracle data in a OS file format that can be imported back into the database. So this is basically for doing backups. And when we use an export in Oracle database, everything is exported in a certain sequence. And we have to have the right security privileges to do this. The reason you want to use export is so you can transfer data between databases. You can create backup files, or you can also do like a normal backup if you so choose. You can import data using the import utility. So export utility is used for exporting the data to a data file, and then it can be transferred back into another input file. There are different export modes. We've got table, user, and full database. Usually, when we start doing a backup, we will probably do a full database and then do incremental exports. So we have table mode, which allows us to export just one table. We've got a user mode, which will export the objects in a user schema. And we have the full database mode that will export everything. So we have to have create session privilege, and you must have full export database role enabled to do the full export in a database. If you do not have system privileges, you cannot export the object. This is how export works. There's just like SQL Loader, the command will take a bunch of value name pairs. If I invoke the export utility, I'm going to have exp command with my username, password, and the parameter file. Or I can just use the command that you see in the second bullet, exp username/password, and then followed by the parameters that are needed. If I end up providing a parameter file, the advantage of doing that is that all the parameter values are consolidated in one place for reference, which is essentially a good thing. These are some of the parameters that you see. So we've got buffer, compress, constraints, feedback file, and full database. So all of these parameters can be provided. And then if you want to log the export as it's occurring, so we can kind of see if there are any errors occur or something fails, we can basically use the export.log. So we can do a cumulative or incremental. Cumulative is basically a complete export that compresses everything. And incremental is like you do a full export for one date, and then you have certain number of like every day you can do a export of the changes that happen in the database. If nothing changed, then the incremental export will not will have nothing to export essentially. So we export whenever we export, we export the table definition and all of its data, not just the change rows. But when we do a cumulative export, it compresses everything into one single export file. Import is the inverse of export. Import allows you to restore data from an export that was done originally. So order in which table is imported is written below. We first get the table definitions, then the data, then indexes, and then any other constraints or triggers. So the process is essentially very methodical, and the export is done the same way. We get the table definitions, the data, any indexes, and then any referential constraints. There are, just like export has 3 modes, import also has 3 modes. So you cannot mix and match though. Like if you export table, or if you do a full database export, you cannot go back and say, I'm going to do only one table import, from the full database. You'll end up doing, you'll end up importing the entire data. This is how the import works. Just like export, you provide a username, password, and a parameter file. We need to have similar privileges like for the export. You need to have create session, export full database, and import full database roles. And these are some of the parameters. So the idea of this slide deck is it's also like a small user manual, if you will, of the 3 utilities I talked about: SQL Loader, import export, and direct load insert. Because you're on a shared system, we do not let you guys use these utilities, but they are certainly there if you end up installing your own instance. And most likely the questions on this will be very simple. They'll be comprehensive, which, you can pretty much look up the answers in the slide to answer the question. So life should be relatively easy. Any questions so far? Everyone can still hear me okay and can see the desktop, correct? Okay. So our next thing is database security. So database security is about controlling privileges to access part of the database. So there are 3 things: privileges, users, roles, and the statements that are used for giving the necessary access. So we can say we have privileges. These are basically nuclear elements that are there for accessing parts of the database, whether it's system or data. These are done through privileges. So we can have a username and password, and that's fine, but to do anything in the system, you have to have a create session privilege. So these are the different types of privileges. You've got database security, you've got system privileges, object privileges, and schema privileges. So when we deal with system privileges, that is to gain access to the database. When we deal with object privileges, that is to access the tables that may be in a user schema. So like if there is a SQL user that has created some tables, not every user is able to access it unless the owner ends up giving access to that user. And schema is nothing but a collection of objects. There are over 80 privileges that are system privileges that are available for access. So some of the examples are like create user, remove table, add table, do backups, and so on. These are all different types of system privileges that can be added for one user. If you are a super user and if you're like the database administrator, you have access to pretty much all the privileges. And there are certain limiting elements that can be added with these privileges. And I'll show you how to grant and revoke these privileges in a moment. We've got the syntax for creating a user in front of you. When you use identified by, you specify the password. And then we have grant, so we can basically say grant a bunch of privileges to a bunch of users. You can always find a list of these in the SQL reference. So granting n privileges to n users can be very messy. So that's why we can assign one specific set of privileges to one user. That's an example. There's an example that's shown right here for your reference. But there's also this concept of a role, because if we have multiple users, multiple privileges, there'll be a lot of tracking that we'll have to do. So what we do is we create a role in between. And then we assign users to the role and we assign privileges to the role. And that role then becomes a bridge between the two. So if a person leaves the company, we don't have to change their privileges. We simply take away the role from them and we are done. So adding a set of privileges to a role, this is what we do. We say create role, grant grant privileges to a role, and then we take the role and assign that to users. So that's how it works. If you want to change your password, which I think I've talked about in the past, you can just say alter user username identified by, and you can put in your new password. So these are object privileges. So you can say that I'm going to give alter table, delete table, execute table, execute index, and so on. So this is how you organize the object privileges for assigning to either a role or a user. Object privileges vary from object to object. The creator of the object has all the necessary privileges and can give access to others, to another role or another user, and they can do that with grant option, which basically means that if I say grant select on employee table to Sue and Rich, then Sue and Rich both can select from the EMP table. And we can also do the same, like, if you have to grant update on, specific columns, then we can do that. Now, if we do it with grant option, that means that Scott can go and assign these privileges to other users. Does that make sense? So if select and insert on department is given to Scott with grant option, then Scott can go out and grant those privileges to other users. So grant walks in and says, let's go on that table department and make it public, which may not be a good thing, but that's what grant option does. And we have to go back and check who has access to what. These are the dictionaries that you can check. You can also revoke object privileges. Just like you grant them, you can also revoke them. So revoking a privilege just removes access for that one user. And if you want to revoke with the privileges that were with cascade constraints, that were given with grant option, then you simply use cascade constraint, which will basically revoke all privileges that were assigned with grant options. This is how revoke works. So hopefully this small segment gives you an idea of how the database security works, and we can look at these ideas. I think for preparing for your final, I would recommend so you need to get to know these topics in a nutshell. I don't expect you guys to, obviously, I'm not going to be putting these from a coding perspective on the final. So you just need you just need to be, you should know the technical content essentially. So these will be part of the final. So let's talk a little bit about your final exam. So your final is currently scheduled on on March 28th from 9 to 10:30. So a week from today, I'll be online just like this, and you'll basically be able to come online, and the exam will have a total of 6 questions. And I'm going to focus on content after the midterm for the most part. So if you look at the content list here, your midterm was after, I believe, assignment 4. So stuff that was covered in assignment 5 and later will be on the final. So assignment 5 content, how formatting works, DML statements, transactions, relational database design techniques, create alter statements, working with partition tables, database security, and database utility. I'm going to focus mostly on that. So I will have you write, create and alter table statements, or create index or alter index statements in the final. So please make sure you know that content fairly well. And of course, if you do lab assignment 8, which you guys will be done with, this will give you a fairly good idea for preparing for the final. So, any questions from anyone in the room? I will be preparing, I mean, you should go through the sample final to kind of give you an idea of what the final will be all about. And I guess today is our last lecture, and if you have any questions, definitely reach out by email or on Piazza, and I'll be glad to assist you. This is all I have for today, guys. If there are questions, of course, I can address those right now. Will I be sending correct answers for, see, each lab assignment, 6, 7, and 8 is built on top of each other. So whatever you created at lab 6, you, like, when you created the database schema, you're using the create and alter statements, and then whatever you have in assignment 7 will be used for assignment 8. So I don't want to restructure your code by sending in my solution, but in the end, if you are interested in a solution, I'm happy to provide you one. Just email me and I'll provide it to you guys. All right? Any other questions? All right, guys, have a wonderful Tuesday. And if there are any other so the topic, okay, I'm sorry, there was another question that just came up. The topic of database utilities and security will be on the final. So please review that, not just for information, but to be able to answer some of the questions on, so like I said, I'm not going to give you coding questions with the database, with the content I've covered today. I'll give you questions on testing the concepts that you may have learned or may not have learned. So I'm just trying to test the concepts here. All right, does that answer the question? All right. Any other questions, folks? All right, everyone, have a wonderful Tuesday. I'll see you all March 28th and for the final. Have a great day.